For this problem, we're going to prove that in a square, AC is perpendicular to BD. So before we do that, and we're also given that this is a square with AC and BD as the diagonals. So before we do that, let's add some points here. So I'm going to put this point here as L, here is M, this is N, this is O, and then this point here is going to be X. That middle is going to be X. Okay. So we always want to write down our given first as our first step. So we know that A, B, C, D is a square, and the diagonals AC and BD are diagonals. And this is given. So 2. So now we have to figure out that one of these points is 90 degrees. So to do that, let's see if we can remember anything about definition of a square. So in a square, the diagonals bisect each other, which means that this is congruent to this, and this is congruent to this. Okay. So we can write that out. So we know that BX is equal to DX, and AX is equal to CX. And this is because of a definition of a square. Okay, so let's see if we can make any congruences. So we know that these are congruent and these are congruent. So look at the triangles. We know all of these sides are congruent because it's a square. We can write that down. We can write down that this, and this, and this are congruent because it's a square. So AB equals BC, which equals CD, which equals to DA. And this is also the definition of a square. Okay, so now we have 3 sides that are all congruent. So we know that this is congruent to this triangle because we have this, and this. So let's just figure out that these 2 triangles are congruent since they have all the sides are congruent. So we can say that for triangle ABX equals triangle CBX. And this is by side congruency. And let's just write down the sides that are congruent. So we know that BX is equal to BX. We know that AX is congruent to CX. And we know that AB is equal to BC. So let's see what that means. So we know that these triangles are all congruent. These 2 triangles are congruent. So this one and this one. So that means that these angles are also congruent. So this angle is congruent to this one. This one is congruent to this one, and this one's congruent to this one. Or the other way around, I believe. Yeah, this one to this one to this one. So we can just like draw that in for ourselves. And then these ones are congruent. So let's see, and let's write that out. This implies that angle L is congruent to angle M. And we'll just write that out because that's all that really matters to us, since we just want to figure out if one of these is equal to 90 degrees. So L is congruent to M. And this is by definition of congruency. Okay, so let's see what else we know. We also see that L and M are supplementary angles. So we know that angle L plus angle M is going to be equal to 180 degrees. This is supplementary angles. So then for 6, we can just substitute. So we know that angle L equals angle M. So we can do angle M plus angle M is 180. This is substitution. That's just substitution from 4. So then we can just simplify. 2 angle M is 180 degrees. That's just simplifying. So 8 angle M is equal to 90 degrees. And that's just simplifying as well. So now we know that one of these angles, we know that angle M is equal to 90. But we said before that angle L equals angle M. So we know that angle L is also congruent to 90. So we can just write that out. All we really need to know is one angle is equal to 90, but we can still show it off because it is good to have as much information as you can. So we can say that 9 angle L equals 90 degrees. This is substitution as well. And then 10, we can say that angle L equals angle N and angle M equals angle O because of vertical angles. So angle L equals angle N, angle M equals angle O. This is vertical angles. And then lastly, we can just say angle N equals 90 degrees, angle O equals 90 degrees. This is substitution. Therefore, we'll put these little 3 dots. AC is perpendicular to BD as angle L, angle M, angle N, and angle O all equal 90 degrees. And there we go.